So welcome to 3 design principles for solving WAN challenges. And notice that we used the word WAN, and that's going to be key throughout. Not SD-WAN, but we'll also touch about SD-WAN. So for today, it is Monday. So by the end of this week, you guys will be experts of hearing this message. This is how you ask questions. Prashant and myself will be monitoring the space. The hard ones go to Prashant, the easy ones go to me. But take advantage of the WebEx app. So with that, today I have my partner in crime, Prashant, that's going to be talking to us later, but now we're going to kick him off the stage. He'll come back later and make some of the stuff I'm going to make up for you guys a reality. And then myself, JeffryHandal. I'm just a nerd, just like you guys. So here we go. What are we going to be talking about today? We're all in the business of networking because we want to build the future. And that's where we're going to start. What kind of future do we want to build? We're going to talk about a little bit about WAN infrastructure because that's the foundation for everything that we do. And then we're going to go into the 3 principles. Now, on the way here on the plane, I got to watch The Big Bang Theory. And while watching it, I realized, our principles look a lot like episodes of The Big Bang Theory. But what do we know? We're not in marketing, but we'll see. Maybe somebody does watch this, and those are future episodes. And then Prashant's going to spend most of the time today making these principles a reality. How do we actually make it happen for you guys to explore the rest of the week here at Cisco Live? And then we wrap it up with a little bit of WAN mastery and how we become WAN masters today. So let's get started. How do we build the future today? Well, we've all seen kind of images like this. Now, in the past, most of these images of what the future came from typically Hollywood. Nowadays, we just get into an AI chatbot and we create the future ourselves with whatever we want to imagine. But you know what? We don't have to rely on this fake future. The future is actually closer than what we think. So this is a little ride in the Bay Area on a Waymo. This is the most polite driverless vehicle I've ever been on. It pulls over to the side, uses the blinkers. It's extremely polite, but guess what? There's no driver in it. So as a good nerd, I took a step back and figured out, okay, how does this world come about? How did they create this? Of course, you're thinking about all the sensors and the algorithm and the machine learning, all the stuff that's on board of the car. But that's self-contained. What happens to, how do I communicate with it? How do we make sure that the people the customers, in this case me, are safe in there and I'm not having an alert, I'm not trying to hijack the vehicle or hack it or what have you. There's a big element of WAN infrastructure that is needed to make a lot of this world reality. So keep that in the back of your heads as we go through this, because infrastructure is key to make a lot of this reality. So as always, there's always a problem, because if not, you guys would not be in here trying to learn something new. Why is this? What's holding us back to making this a reality? Why is it only in the Bay Area that we can do this? Well, the real world is very messy. And guess what? We depend on each other to make the internet work. Just look at your neighbors next to you. They probably are the SP. They're the ones that probably hold your infrastructure applications in the cloud. They're probably the ones that give you your software services. We're all in an ecosystem, all in this together. But it's not easy to make all this stuff together. It's very complicated. But let me make it a little bit more personal for you. So typically, what you have is a mess that either you made or you inherited, right? I see some nodding faces or smiles because you know this is true. Second, there's a little bit of a shadow IT, and I bet with a quick raise of hand, most of you guys have been guilty as charged, right? Doing stuff you're not supposed to in your businesses, right? Running applications that are not allowed, especially AI stuff. Well, this is the reality we live in. There's a lot of management points to make all these things work, but above all, there's a lot of cost and bad experiences. Many times, you don't hear your customers complain, but they're complaining. Hell, sometimes we're complaining about ourselves with our own Cisco IT, because we're also customers of theirs. But also, you come to Cisco Live, you talk to Cisco because you ask us for things, right? You guys asking us to make things simple. You will see this team come throughout the event today. You want things to be predictable, right? You're always asking me, if I configure this 10 times the same way, I want the same outcome. You don't want it 9 times out of 10 working. So you want things to be more and more predictable, especially as we get into this new world of AI, where, as you guys know, it's not as predictable as we thought or we'd hope. Sometimes it can't even add 1 + 1 = 2, stuff like that. And last but not least, we're all under big pressure to deliver stuff for the business. So we need to make all these things simple, predictable, so we can deliver outcomes for our businesses. So we got to remember who still pays the bills, which is the C-suite, and we need to make them heroes. So with that, as hinted at the beginning, this is a lot about WAN infrastructure. Without this reality of WAN infrastructure, none of this works. We saw that in the Waymo. But what if you were put in this situation where you show up to a glamping tour that you scheduled, and you get there, and you see this sign: we do not have Wi-Fi. So what do you do? Get a cellular gateway. That's a good one. But there is no cell phone in the Sahara Desert. Trust me, I tried. There's Starlink. Yes, I also thought about that one. Problem is, legal boundaries doesn't work in Morocco. So all this infrastructure, and while it's all around us, is not available. And while being in the sun toasting, it made me think, okay, what does it really take to make the real world, the digital economy work? And these are just a few little things I was thinking about. Again, I was toasting in the sun, not fun, with no internet. It was quite an adventure, kind of relieving, but every one of you in this room plays a big role in creating the world that we live in, and it all starts with infrastructure. But it's interesting today that we have two types of infrastructure that we can take advantage of. One is wired infrastructure, which is what most of us grew up with. That's the analog world, that's fiber, stuff that's put in the ground. But what's fun, which many of you guys were just mentioning, is we have these new forms of wireless communication, which is through cellular, or what I like to call low Earth orbit, or Starlink, like some of you guys mentioned. So which makes things a little bit more dynamic, a little bit more accessible for the masses. And that allows us to get into types of architectures. Again, some of the stuff I'm covering right now, it's not earth-shattering just yet, because we've been doing this for the last decade. We've been doing what we call, this is a marketing term, by the way, SD routing. What Prashant and I added was the word secure, because one of the things that we want to emphasize, and we'll hint this in one of the principles, is everything that you do, you have to do with security in mind. You don't leave that up to the security guys, because guess what? Everybody in this room is now a security guy. You can't let the bad guys win. And then there's the other classical architecture, which is the SD-WAN. Again, we're adding the word secure, because always think about security in everything that you do. Again, nothing new. These are normal architectures. And this is what we see everywhere. Now, these next set of diagrams, again, nothing new. This is stuff that we've been doing for the last decade. Creating edge architectures with single WAN, double WAN, more than 3 or 4 WANs, depending on the parts of the world where they're unreliable. When you want to have active, again, nothing new, not yet. But what's getting more interesting is we take those same edge architectures and we start adding those wireless ones that we just talked about, because it's becoming a lot more reliable. Now, I know it's scary to think, oh, how can I operate off of a Starlink? Or how can I operate out of 4G, 5G? Well, guess what? It actually does work fairly well. You can have WebEx meetings. Yeah, you get the occasional hiccup and stuff like that, but that's why we're going to discuss another principle to how do you deal with those things. And again, nothing new here. Same architecture, new forms of integrating wireless infrastructure into your environments. But just remember, it's WAN infrastructure we're discussing here today. Now, taking a step back and looking, why do we make all these fancy WAN infrastructures? Because we want to get to places. We want to get to our cloud service providers. Take your pick, whether you like Azure, AWS, GCP, Baidu, wherever you're operating. It doesn't matter. People are trying to go somewhere. And this is why we need those WAN infrastructures. Those last miles that you have control over, we still want to get to somewhere. And the reason we want to go there is because this is where work is done in the modern world, right? You don't connect just for the sake of connecting. You connect in order to do something, to drive purpose, to generate revenue, to whatever your line of business is. Move records around. If you're in healthcare, you want to move x-rays, save a life. That's why we're building all this infrastructure for. So with that in mind, We're going to take a step back and go where we started with this very complex world that we have some control over, some we don't. And we're going to derive these 3 principles that we want to impart on you. Some of it may be controversial, some of it may not, but we're here to provoke you guys a little bit. So let's take a look at the first one, the trust principle. So before we look at the trust principle, again, very classic example. You have a branch. You may have 1 or 2 routers. Your SVIs may be on the edge, maybe on the switches. That's not the point. It doesn't matter. But you may have ISPs that are single IP address, so meaning that you have IPv4, they're dual stack, IPv6, IPv4. This is the reality we all live in, no matter where we are in the world. Some of you guys may be facing mandates. So in the last year and a half, the number of countries requesting IPv6 has doubled. But what's more interesting is IPv6 only is what's being mandated. So again, you guys have to keep this in perspective. Or sometimes you will say, okay, well, I'm trying to figure out this WAN infrastructure stuff. How do I connect? Do I connect with v4, v6? Do I get rid of v4? Do I do this thing called IPv6 mostly? And there's talks about all these 3 things later on in the week, so go explore. But these are things that you have to contend with. But does it really matter? And in full disclosure, I'm a self-proclaimed IPv6 evangelist, so what I'm about to say is going to really hurt. It really does not matter if you're doing it with v6, v4, because this first principle that we want to introduce to you guys is all about zero trust, thinking about zero trust, where it doesn't matter what IP family you have to connect to. It should not matter. So let's unpack this principle a little bit. One of the elements in this principle is the notion of identity. Now, for the last decade, we've thought about identity as your username and password, or your MAC address, and all these old constructs. Well, the key word, they're old. If you have not kept up with the times, by the way, who's heard of give me 1 second, what's the name of this hack that just took place with a lot of the ISP? Sorry, I'm jet lagged. Salt Typhoon, thank you, appreciate it. Salt Typhoon, well, if you look at Salt Typhoon, the way that they got in is they didn't have to go bang on the door. They just walked in, they had credentials. So nowadays, attacks are focusing on your credential and just walking in through the door. So this is why this concept of zero trust is even more important, because you got to go beyond just simple credentials, a simple MAC address, a simple IP as an identity. So you have to evolve it, and you'll see some of that throughout Cisco Live this week, that we're evolving our identity play and zero trust play because of this and because of Salt Typhoon. Next, of course, with zero trust comes segmentation. And many of you guys in this room, we kind of saw some of the credentials of who you were. Many of you guys are networking folks, which means when we think about zero trust, we think about segmentation. We think about SGTs, TrustSec, all these come into play, and Prashant will bring some of this to life. And last but not least, we got to mix all this up with policy. Now, on this policy front, it's been very interesting in the last 48 hours, because the federal government just issued a new mandate where they want to be a prime player in the cyberspace world, meaning they want to be more proactive, and they want to take a stance in leadership in the world in terms of cybersecurity. Now, that's not what caught my attention with that mandate. What caught my attention is they want to do things in a way that they want to do rule as code, meaning they want to turn these policies and these rules that the security groups typically can put and convert it into policy automatically, which means we're automating this zero trust story. So keep an eye on that, because it'll see how that evolves. Because typically we always have these policies, and we're trying to figure out how do we interpret it. And that's a very manual process. The government's trying to make this as automated as possible. And why I like this principle of zero trust is because typically infrastructure is always viewed as a cost element. And that's always a negative, right? In our minds, oh, we're always cost. We're always a cost center. That's not good. Well, when you start connecting WAN and policies that you can enforce, policies typically put you on the map with the C-suite, because now you're starting to talk their language about company strategy. And if you can automate that, now you're onto something. So that's the zero trust the principle. We're going on to the next one, the augmentation principle. So what do we mean by this? So imagine you rent out a space like a WeWork, Regus, and by the way, none of this is an endorsement to any of them. Just take your pick. You buy access to the space for the conferencing, for the Wi-Fi, for their nice kitchens, because you want to have a coffee machine for your employees. You want to have access to Cokes when you bring in customers. Or in my case, I don't drink either. I do bubble tea, but I don't know how to use the bubble tea machine. But these are really nice spaces that you have access to. I can't use that machine. I can't use the nice oven and all these extra things, which, by the way, you're paying for. Just because you don't access them doesn't mean you're not paying for them. Well, what does this have to do with Cisco? Well, when you guys buy our kick-ass technology, you don't use half the stuff. That's a problem, right? That is a big problem. You paid for it, and you're not using it. There's many reasons for that. You don't know, you don't have time, or sometimes you have 5 years, you replace it, and you never took advantage of it. That's a big problem. Very, very rich, feature-rich platforms. So this is where this next principle comes into play, where we have to think about how do we start automating what you're consuming. And this not only applies for Cisco stuff, this applies for anything that you have in-house, for anything that you do. But we're not going to leave you hanging that you have to go figure out your own automation story. We're doing a few things that you're going to see throughout the week here at Cisco. One of those things is going to be this thing called secure default on. I added the word secure because I'm always thinking about security, as I hinted at the beginning, and it kind of ties in with the first principle. And what this means is we're going to be turning things on by default. So we have a plethora of data for the last 20 years of what you guys have been configuring, whether it's connected to the cloud or on-prem. We know what you guys have been doing. So with 90% confidence, we could probably say, yep, 90% of the people will use this feature, which means it'll just be easier to adopt the technology. You don't have to wait a cycle or figure out, okay, what do I have to go turn on? The other thing with this is we're also, because of the word security, we're looking at how we are secure by default as well. Because how many of you have actually looked at hardening guides? There's many of them, right? I see a few hands out there. Well, why? Let's just start on with our security already turned on. So in the future, you might start seeing things like loosening guides. I'm not in marketing, so I don't know what they're going to be called. But it's a different mindset. That way you start with security in mind, and you start turning stuff off that you want to, at your own risk, be exposed. So again, new mindset shift that you're going to see at Cisco, but also start thinking about that not just for Cisco stuff. How do you do that for the rest of your technology that you own? Next, we're starting to put everything together. So yes, Cisco has over 260 acquisitions, and we all sometimes act like very different companies, but in the last 2 Cisco Lives, and you'll see more of that this Cisco Live, we're bringing the family together more and more, sharing the same common services, meaning that if something we say is Facebook, it's Facebook in all platforms. It doesn't matter which ones they are. That reduces the chance of making mistakes. And last but not least, we've been on this journey for API first, right? But I'm adding the word consumable because not the barrier to entry for APIs usually has been left for people that know how to develop, or the service providers that like automation. We want to make it accessible for everyone, so we want to make it a lot more consumable. And the end goal of this principle is to make consuming this Cisco tech very easy. That way we don't have to go figure out where the documentation is. We just want to make it happen. And going to the last principle, this is what I call the March principle. And we'll see what that means in just a second. Imagine you have a maintenance window. Typically, you talk to your change management probably a month before. Hey, we're waking up at 3 in the morning, showing up and doing a firmware upgrade. Pretty standard, nothing earth-shattering there. You do your maintenance window between 4 and 7, everything goes fine, it reboots, done. You make it till 7 because at 7, Starbucks opens up. And then what do? Do you assume that it all worked? Or do you just are the mindset that you're OCD, you need to figure out, okay, is it working? Is it working? Do I wait? Or what happens? So I think in this room, we're probably 50-50, if I had to guess. What was that?
Automated testing.
Automatic testing. That's one of the concepts that Prashant's going to bring to life here in a little bit. But we're kind of in this world, right, where we have to figure out what's going on. And this is what this new principle is called, the monitoring architecture principle. And what is it? It's just a fancy way of saying measure and automate everything. Doesn't matter what it is, whether it's security, performance, just add it in there. If you have a metric, use it. And the reason you want to do that is because things have changed a lot in the last decade. Applications used to be very deterministic. We all used to Google the same 2 words, and we all got the same results. Well, that's no longer the case. That ship has sailed. Apps today are very probabilistic. If you ever had to troubleshoot something, you don't know if it's using QUIC, TCP, what kind of encryption is it using? Is it located in Dallas, or is it going to LA? Depending on where you are, what VPN you're using. I mean, it's a very, very complicated world, so it's not fun to troubleshoot this, which is why you need to arm yourself with a lot of data to make your life easier. And that's by design. Trust me, the IETF is going overboard with privacy and encryption and making our lives a lot difficult. So we have to do something about it. And what this principle entails is always think about data as a transformation method. There's always that security angle always coming to light. It's not about preventing an attack. It's not about preventing compromise. It's just about minimizing risk. There's always going to be a risk, but you just want to know about it as quickly as possible. And last but not least, measure everything. I can't harp on this one enough. And the reason we want to do that, there's that word, AI. Once we start measuring stuff, that's just the beginning of the story. That's just to make our lives easier. And with that, now that we've introduced the three principles, we're going to invite Prashant to bring them to life for us and dive a little bit deeper into the technical side.
Thank you, Jeffrey. I think let's get into reality a bit. Sorry, it's working. So as Jeffrey has talked about earlier, so we have had multiple platforms. One is for multiple for on-prem, multiple for cloud. But slowly, we are getting into a situation where there are fewer platforms, like fewer platforms for cloud, or fewer platforms for on-prem as well. But eventually, the goal is to get single platform for cloud and on-prem as well. And it's all about delivering experiences to right set of users and respective users we have got or you have got. If you look at NetOps, SecOps, or CloudOps, or even AIOps, multiple ops users in reality. And part of it, if you look at admin experiences, which is very much key, because being a NetOps, SecOps, or different ops team who has to configure things, build infrastructure, define the policy, they all want to have same experiences, right? So even though there are fewer platforms right now, they are able to get same kind of experience, which could be Cisco Secure Access, which could have Cisco SD-WAN Manager, which could have Meraki dashboard, or which could have even Catalyst Center kind of things. So the experience to admin right now is pretty much the same, even though there are fewer platforms. But going forward, at the same time, if you look at developer experiences, where our developers want to build infrastructure, define things via API, automate things, so API module and data plane is pretty much same. So it's all about delivering experiences to respective set of users, and which is getting there in reality. Common hardware, I think Jeffrey has talked a bit earlier about trying to have converged experiences. If you look at the top, the wireless has been pretty much common since a while. Switching has been pretty much common since a while as well. But the bottom part, which is routing, which is the edge, which is going to be a WAN edge, which is already a WAN edge today and tomorrow, is pretty much going to be common as well. And you might hear the announcement sometime in this week, where we are coming up with the single platform, which could run Meraki and Catalyst kind of stuff as well at the same time, or maybe the situation use case you might have got, you want to use Meraki in the same box, you could run that, or you could have Catalyst SD-WAN kind of functionality in the same box, you should be able to. So single hardware could run as respect to images based on requirements. So that's something as a common platform going to be there soon, which is going to be announced as well. And in terms of licensing, it is going to, again, essential advantages, which you might hear a lot in sometime this week, part of the announcements. Now, when it comes to experience in terms of configuration or definition, whether it's policy, templates, or manageability, Cisco workflows comes into picture, which could eventually manage, configure multiple Cisco dashboards, which could be, again, ACI, Meraki, our Cisco SD-WAN, our Cisco Catalyst Center kind of stuff. At the same time, Cisco Secure Access could be one of them as well in terms of pushing a policy. At the same time, if you have, let's say, third-party resources or third-party solutions, the Cisco flows could be something which could act as an interface to define things altogether. And there's a lab as well. If you want to learn more about that, there's a lab as well. So if you join the lab, I think they are talking about and letting the customers know how exactly the workflow is playing the role and defining, configuring policies and managing things and bringing things all together as a zero-touch method. Now, Jeffrey has talked about all three principles, and we are trying to get into all three principles, how they come together, especially trust. He talked about security. At the same time, how exactly the augmentation, which is more of automation stuff, comes into picture. We'll talk about that as part of cloud networking. And monitoring architecture, which is where visibility comes into picture, how exactly you could have visibility about every single resources, things, infrastructure, applications you would have at the on-prem level, cloud level, multiple cloud level as well. Now, before we talk about how exactly security comes into picture, our network infrastructure can be defined, the visibility becomes key, right? Every single Cisco SD-WAN devices or non-SD-WAN devices and Meraki as well, there's a DPI engine. The NBAR comes into picture. Now, you might all have heard about NBAR. So NBAR is basically the application engine that can recognize and figure out and identify the applications or uses or applications being running or traffic being flowing about from the devices or every single device you might have got. Again, NBAR has multiple ways to figure things out, which could be session behavior, session pattern, session definition, maybe FQD, and maybe URL and things, a lot of things, right? Now, this visibility is not just visibility to get the information about things, but also this visibility and this application signature can let you as a customer, as a NetOps team, to define a policy and say, you know what, application A should do that, or application B should go at that, application C should be inspected. So you could have application visibility and also application steering as well at the same time. And also, in addition to NBAR, the SDAVC comes into picture. I'm sure you might have heard about it. You might have seen a lot about it. So SDAVC is one thing which could be on top of NBAR and let your experience of application could be better and enhanced as well, and how it can make application experience better enhanced. Because if you look at, no matter what kind of engines you have got on the devices, it's very, very difficult to figure things out. What is my application? It's like first packet goes there. So SDAVC could be an engine, can let a session identified from the first packet itself. That's one. Second, it can enhance the user experiences. For example, one of the site has access application A, B, C, or something. It can go ahead and distribute the information of application to every single site you have got across the fabric you have got. And based on that, now every single location and sites, when they want to go to that application, their experience are going to be so better, or way better in reality. In addition to that, the world we are in, it's more of decentralized and distributed. You might have many applications which are more of custom application. With SDAVC's help, you can define a custom application based on port number, protocol number, URL and things, and based on that, you can define kind of policy thing. You could also have visibility about custom application and things like that. Let's get into more of connectivity and how exactly security comes into picture. When it comes to WAN, right, I think Jeffrey has talked about a lot of things, how exactly you plan your high availability of the devices, how exactly you talk about and plan your high availability in terms of link, technology, and a lot of things comes into picture. At the same time, security comes into picture with equal importance in reality. Now, when you have to design and define the security, there are multiple modules or multiple ways you could define as a NetOps user or as an admin who has to plan all the security concept altogether. And with Cisco SD-WAN or even non-SD-WAN as well, which could be Catalyst or Meraki, the security is completely flexible. That essentially means, by nature, by default, every single device that Cisco has got inbuilt security. That essentially means all the security functionalities you will need, you can enable on those devices as well. In addition to that, there are functionalities and security stuff you might need, which can only be provided by security, which is more of cloud security gateways, like Cisco Secure Access things. So with Cisco SD-WAN flexibility, every single devices and locations and things can also have integration with Cisco Secure Access or cloud security in terms of cloud security inspection. That essentially means you could have a policy and say, you know what, application A should go to Cisco Secure Access or maybe SSC for inspection. Application B could can do DIA, or direct internet access kind of stuff. So you could have flexibility to define and bring security to your branches, campus, location, and data center. At the same time, if you would like to look at the world we are getting into, you have a lot of co-location and backbone built in as well. Now, with this module, which is more of flexible security, you could bring security stack to every single co-location or edge point. And with that, you could say, you know what, policy, I want to inspect these applications going to my backbone or going to my cloud or multi-cloud data center via the backbone firewall I might have got, which could be into Equinix or Megaport kind of locations as well. So it's all about flexible security, and you can bring the security based on the need, based on the situation, and the architecture you might have got into your network, right? It could be like small architecture, it could be global architecture, and with this flexibility, you could pick the right security at the right place. Now, I'm sure you all have been using a lot about segmentation. Now, segmentation has a multiple forms, a multiple way, right? A segmentation is more of network segmentation, where you could think of old school segmentation, where you have multiple VRF, multiple VPN. VPN or VRF1 could say, you know what, should be completely enterprise. VPN2 could be something completely guest. VPN3 could be something, let's say, IoT. 4 could be printer kind of stuff. So you could have multiple VRF or VPN stuff, which can also provide a security or segmentation within your campus or branch and locations as well. But in addition to that, identity has become a key role. I mean, it's playing a big role in reality. So one is like a complete segmentation of route table, but another could be like segmentation of user level as well. So with user level segmentation, more of identity, in addition to having those old school segmentation, you could define a simple policy at every single branch level, which could be essentially all the way from your switches, which is campus, all the way to the WAN, and also all the way to your SSC POPs as well. So you could have same kind of security module and say, you know what, this identity or this user should be inspected here while going there, or this user or this identity should be inspected at the SSC level, or should have these kind of security policies as they head towards the cloud or wherever the applications are. So it can provide a same application experiences, and I would say security experiences to the applications users are accessing in reality. And if you look at this has more detail, imagine a user going to the cloud, or maybe going to 2 different applications. One has to go directly, which is more of DIS. You could say, you know what, this identity should be inspected at the branch router level and have this kind of firewall policy applied, done. And then user goes to SSC as well, because there are certain things they have to do at SSC level and before they go to certain SaaS application, because there are functionality like CASB and DLP stuff that's only available on SSC level. So you could say, you know what, now this identity could have these policies at SSC level too. So number one, you can always play with inbuilt routing policy at SD-WAN, Meraki or Catalyst to steer the traffic. Number two, you could have security policies, more of distributed enforcement model to apply the respective policies at respective places at the same time. And at the moment, the Cisco Secure Access does understand identity, and Cisco SD-WAN does understand as well. So that essentially means you could have one common identity across the fabric, and also enforcement of the security could be completely distributed in reality. Now, how many of you are doing multi-cloud networking these days? I'm sure a lot of you. Amazing. Any specific cloud you guys are working on these days? Azure, AWS, Google? Nope. It's your Google. Amazing. So when you go to the cloud like AWS, Azure, and Google, the cloud providers are really good with compute, storage, and services they provide. The places they like a lot is like right now is networking and security. Because every single CSPs have very different networking architecture and constructs. Every single CSPs have very different security architecture and constructs. At the same time, they're so weak. They're so weak in reality. And to address those challenges, we've acquired a company called Valtix, and now we call it multi-cloud defense. Now, multi-cloud defense is nothing but on-demand security edge, which can reside into every single CSP, into every single region to provide a customer a strong and robust security across every single CSP and unified manner as well. And that is completely and highly scalable, and which is completely SaaS-driven platforms. That essentially means it is a platform which can help you as a customer to secure every single CSP you have got, every single applications you have got into the regions of the cloud, which could be AWS, Azure, and Google, without thinking and working and learning about 3 different products. And those products are technically so weak in terms of security, because that has become key. Now, it's not just security as in cloud levels to application, but also if you look at containers, Kubernetes, a lot of things comes into picture. So we need to have security more than that. And that is something we're not covering here, but here we are covering more of network security in the cloud. In addition to securing the cloud, because that's the place your applications are residing, because things are so decentralized. Like every single customer I'm talking right now, they have workload in AWS, Azure, Google, data center, a multiple data center, a multiple region of the cloud as well. So security becomes key there, because they don't want to backhaul things to our data center every single time. Now, in addition to that, when you go to the cloud, like Jeffrey talked about application hosting, this is like typical architecture in a simple way. It's too complex, right, by nature, if you look at. So if you look at this, like AWS has a multiple way to connect. One is more of connecting via direct connect, which is more of private link. Or you could also connect AWS via traditional IPsec concept, IPsec VPN, IPsec-I kind of thing. You could also connect AWS via using transit gateway or cloud WAN stuff. And also, you have to keep in mind a lot of limitations like IPsec throughput, performance, and also how many prefixes direct connect can send all the way from your branches and campus to the cloud. When you go to Azure, you have pretty much same thing as well, because you could connect Azure via IPsec-IKE, or you can connect Azure via Express Route as well. Now, you have to keep in mind, like IPsec-IKE limitation, you have to keep in mind the number of prefixes you can send over the Azure Express Route. A lot of things, a lot of challenges, a lot of things you have to keep in mind. When it comes to Google, pretty much same. So this is typical architecture. And this is where Cisco SD-WAN comes into picture, very high level, that simplified cloud networking from all the way your branches, from your branches, campus, and data center to every single CSP. That basically unifies networking constructs from the bottom to the top, extending SD-WAN fabric all the way to AWS, Azure, and Google, and letting NetOps and I would say NetCloudOps leverage cloud native constructs at the same time with Cisco SD-WAN altogether. Now, this is more of high-level picture. So in this, mainly, we're talking about extending the fabric all the way to AWS. We can also have multi-cloud defense to secure every single region of AWS. At the same time, when we talk about Azure, we are using basically virtual hub of Azure and extending Cisco SD-WAN fabric there. At the same time, Google, we use NCC concept. But in addition to connecting the CSPs, we also have got flexibility. How exactly would you connect to CSPs? You can connect CSPs, which is cloud service providers, via internet. Also, you could connect CSPs via Megaport and Equinix that can provide on-demand direct connect, on-demand express route, on-demand interconnect to those CSPs as well. And if we get into a little more detail about how exactly it happens, so in AWS, we have 3 models today. Number one, you could extend Cisco SD-WAN fabric in order to connect your workloads and applications you have got into AWS via Cisco SD-WAN and using transit gateway constructs of AWS networking into AWS regions in a simple way. That essentially, it can offer a one extension, one fabric all the way to the cloud of AWS without having limitations of IPsec-IKE tunnels. And the second model, called AWS Cloud WAN, I'm sure you guys might have heard a lot about it. So Cloud WAN is more of a managed service backbone AWS has launched a couple of years ago. So in addition to TGW model, if you say, hey, I want to connect my AWS, but I want more of Cloud WAN model, so with Cisco SD-WAN, it's the same flow, same principle, can extend all the way your workloads and reachability from the branch all the way to the cloud as well. The third model is more of connecting the AWS, but let's say if you have just 1 or 2 VPCs and you want to connect the AWS without having SD-WAN fabric, you can simply go ahead and build IPsec-IKE from Cisco SD-WAN branches all the way to TGW. Now, every single of these models I'm talking here is completely automatic and also completely certified, and it's something is what every single customers are doing. It's more, I would say, more scalable, and also it's something can be very much certified with security stack on demand there. When it comes to Azure, now Azure has very different constructs as compared to AWS, right? So when it comes to Azure, if you look at first model, it's nothing but we are building basically a virtual hub, virtual WAN of Azure. And also we are putting Cisco virtual devices into Azure Virtual Hub as NVA construct, or concept, I would say, which is nothing but network virtual appliances. And then we are discovering every single VNets and connecting with Virtual Hub so that every single branch at the bottom should be able to reach the workloads as a cloud ops, as a customer you have got into Azure. Now, many customers we have been working on, they have mainly a requirement of using Azure Route Server as well. So there are a couple of models Azure has got. One is like virtual hub model. Second is like Azure Route Server. So you could also do with Cisco SD-WAN the second model called Azure Route Server, where you could have transit VNet with Cisco SD-WAN devices, and you could build reachability to Azure Route Server as well via BGP. And behind the VPC, we have got a VNet you have got as a transit VNet. You could connect all the VNets you have there. So that essentially means every single, I think doesn't work. So every single VNet you have got there, they'll be connecting to Azure Transit VNet, and from there onwards, Azure Route Server will advertise every single reachability routes to SD-WAN devices in Transit VNet, and from there onwards, they can reach to every single branches. And last option, which is more of, again, virtual hub, the only difference is like between first and last. Last one, the virtual devices of Cisco SD-WAN is a separate device. It's part of Transit VNet. It's not part of a NVA construct. That essentially means they are building IPsec IKE tunnels from Transit VNet all the way to the virtual hub and BGP. And behind virtual hub, all the VNets are paired in reality. Yes, go on.
Isn't the second model what cloud on ramp for IaaS used to be?
Back in days, no, I think none of these models been part of cloud on ramp infrastructure service. Sorry. Yeah, so questions like, is the second model is what Cisco Cloud on Ramp infrastructure service back in days was doing? So the answer is like no, because Cloud on Ramp infrastructure service, what we had back in days, it was nothing but a transit VNet, and then we used to build IPsec IKE to every single VNet back in days. And it was not scalable model. Imagine you have 10 VNets or 20 VNets, and you are building back-to-back IPsec IKE tunnels, and monitoring the number of tunnels and scaling that was nightmare. So if you look at the first model is what we do as right now, cloud on ramp, multi-cloud workflow, the first model, which is NBA. Second and third model is optional, which people can do by Terraform modeling or manually as well.
Are these all within the same code release, or is there a requirement?
Yeah, so the question is like, are they part of same code release, right? So any of these models, like first one is completely automatic. That's available from 20.4 onwards. And the model 2 and 3, technically, it does not depend on any release. As long as there's Cisco SD-WAN Cat 8K is available into cloud, they work with the model. So essentially means you can use like 20.4 release onwards, any release, all the way to use any of these models in reality.
And from licensing point of view,
yeah.
Is there anything special?
Yeah, so the question is like, is there any special thing with respect to licensing? So there's nothing special, to be honest, because ultimately we don't charge for automation. So it's like two virtual devices. To Cisco, as a customer, you're going to pay for virtual device licenses. To Azure, you're going to pay for the compute prices in reality. Thank you. Any other questions you guys have got for me? Yes, go on. Yeah, so the question is like, right now with every single CSP, there's IPsec limitation of 1.25 gig, right? And same is applicable to Azure as well. So with our solution, if you look at the tunnels we are building, all the way from the bottom, the branches side, to the AWS, it's IPsec UDP-based tunnel, what Cisco supports as SD-WAN. So it does not have any IPsec 1.25 gig limitation there. And if you look at within Azure as well, in the first model, there's no IPsec IKE because we are hosting Cisco SD-WAN devices as part of NVA, which resides as part of Virtual Hub itself. So there is no IPsec 1.25 gig limitation there. However, Azure has something called a rate limit there right now because they block UDP ports. So what we are doing with Azure right now is working with them to whitelist those things to make sure like every Cisco SD-WAN customer should not fall into the rate limit they have got today. At the moment, we are able to deliver like 40 gig performance per Azure regions, which includes 5 virtual devices. Does that answer your question?
It does. So it will support the native bandwidth. Right?
Sorry about that. Can you repeat that?
So it will support the native bandwidth?
Can you hear me now? So it will.
Yeah.
I'm asking. So these tunnels
Yeah.
will support the native bandwidth. of the circuit?
So can you describe native bandwidth basically here?
Like if we have a 5 gig circuit.
Yeah, exactly. Yeah, so any kind of circuit you have got, let's say if you've got 10 gig circuit from the branches all the way to AWS, Azure, or 10 gig circuit, 10 gig or 5 gig or 15 gig should be fine. So the tunnels are going to be 15 gig tunnel, or 10 gig tunnel, or 5 gig tunnels basically.
Excellent, thank you.
Yeah, there is no 1.25 is applicable here at all. Thanks for the question, by the way, appreciate that.
The V1
I have a question.
deployed, or do we have to have the V1 in place before we spin up?
Very good point. So the question was like brownfield support or greenfield. So right now, it's completely greenfield and brownfield, both the support. So if you want to completely deploy the automation to the cloud, just define the credentials. By the way, I'm doing a session on this completely in detail tomorrow at 4 p.m. If you guys want to join, feel free to. So very high level, you can define the credential of Azure into Cisco SD-WAN Manager. Once you define that, we'll go ahead completely automate VWAN creation, virtual hub creation, Cisco SD-WAN creation, and discovering the workloads you have got. At the same time, let's say if you're a customer who already have a virtual hub, which is more a brownfield, we can discover that and deploy Cisco SD-WAN devices inside it in reality. Yes, there was another question there.
Where is this 1.25 gig limitation?
Yes. Yeah, so questions like where exactly 1.25 gig limitation comes into picture. So basically when you connect any cloud, let's say AWS, Azure, and Google, they have cloud native IPsec challenges today. So when you build reachability to, let's say, AWS TGW, for example, so directly, natively, so that tunnel is going to be 1.25 gig limited. Let's say if you build IPsec from your branches to Azure's virtual hub, you're going to have 1.25 gig limitation on that tunnel. That's why SD-WAN comes into picture to take care of those challenges and says, you know what, don't worry about that. We will take care of it. We won't let you fall under 1.25 gig limitation because Cisco SD-WAN is going to reside there as well.
So that's a service we have to buy from Azure?
I'm sorry?
That's a service we have to buy from Azure?
No, so you don't have to worry about that. So this is going to be Cisco SD-WAN basically. So once you have Cisco SD-WAN all the way to Azure, or AWS, and Google, the 1.25 gig limitation completely goes out. Yep. Because their cloud native tunnels encryption they have got, that has challenge. And because we host Cisco SD-WAN devices underneath the cloud as well, so IPsec is from that edge device to the SD-WAN of Cisco. That essentially means that part is completely gone. Yep. All right.
My question is around
One more.
I'm sorry, so virtual WAN from the cloud?
So you're running a virtual router that's on the cloud, so you're taking
Yeah, exactly. So thanks for the question. Yeah, exactly. The question, point is like, yes, we are running virtual WAN, virtual hub within Azure. And within virtual hub, we have Cisco SD-WAN devices as NVA, like they're hosted inside that. And from those routers, we're building Cisco SD-WAN tunnels to the branch and campus. So basically, as a customer, the moment you have a bunch of VNets, right, you would need virtual hub because of peering, because that's how the scale challenge comes into picture. Plus, if you have distributed apps as well, you would need that multiple virtual hub, one per region. There are many things I can talk about, but just very high level. Cost is basically your virtual devices, what you're putting into your cloud. But that is needed because you have scale requirement, you have security requirement, you might need a policy, you might need to have multiple transports, a lot of things we can talk about. But we can do one-on-one if you want to later on. Thank you. So pretty similar to Google as well. Google has a couple of models we support. So essentially, the first model is completely automatic, where we create all the VPCs like WAN VPCs, site-to-site VPCs, site-to-cloud VPCs, Cisco SD-WAN devices underneath, and also building reachability from the branches to Google as well, discovering Google's workload like VPCs, and building peering as well. In addition to that, we use NCC. Now Google is calling it Cloud WAN of Google. So NCC is working as an underlay there. So that essentially means NCC is basically letting Cisco SD-WAN devices to speak to Google Cloud Routers as a BGP. So every single workload should be reachable to Cisco SD-WAN within the cloud, and from there onwards, they can have fabric of Cisco SD-WAN. Second model is basically very much old school model in reality, where we can have, without NCC kind of stuff, we can simply do Cisco SD-WAN devices and peer all the VPCs with the site to cloud. And third model is pretty much, I would say, going forward is future model, is Cisco SD-WAN devices, not future model, I would say. The third model is basically old model, not completely new model, where branches can directly connect to Google NCC using HAVPN concept of Google. But that is where, again, you have to think about 1.25 gig limitations. So if you want to avoid that, go for first model. One other thing we want to talk about is also a Megaport Equinix. I know we have very less time, and Jeffrey's looking at me. So essentially, in addition to connecting the cloud directly, you could also use Cisco SD-WAN, and also the integration Cisco has got with Megaport and Equinix that essentially can let you connect every single cloud via direct connect, express route, and interconnect. And in addition to connecting, you can create on-demand connectivity as you would like to, because it's completely single dashboard, single interface experiences with one credential in reality. And more than that, it's also making a buying experience better. So you can buy it from Cisco, like entire Megaport stuff, entire Equinix stuff all together. In addition to technology, it's going to be one experience, right? So essentially, you're going to host Cisco SD-WAN devices into Megaport and Equinix, which is completely automatic. And from there onwards, you can have reachability to every workloads you have got into respective CSPs, into respective regions and reality. A lot of customers are been building their backbone since a while. If you look at like every one of you have got global backbone, global infrastructure in reality. But now with Cisco SD-WAN, we can offer on-demand global backbone, essentially which could be powered by AWS, Azure, Google, Megaport, Equinix. That means you could connect your site to site, region to region, country to country locations, branches, applications using Cisco SD-WAN's fabric and underlay of these CSPs as we have got. Now, at the same time, Jeffrey has talked about visibility is the key. No matter what infrastructure, what connectivity, what security model you have got, visibility is the key. That essentially means every single thing you have deployed it to on-prem, every single thing you have deployed to the cloud, every single thing you might have at co-location, outpost, or maybe many locations. The visibility becomes key, and that's where Thousand Eyes comes into picture to provide the visibility about every single thing that's happening to your campus, branches, locations, cloud, multiple cloud, powered by Cloud Insight of Thousand Eyes. That essentially means it can give you information like what's latency, loss, and jitter, what exactly have happened there, or what could go wrong in the future in reality. So visibility is the key piece in order to drive M architecture, which is one of the principles Jeffrey has been talking about earlier. At the same time, visibility could also be a form of NetFlow. So essentially, you could also define NetFlow infrastructure or NetFlow reachability and IPs and location thanks to Cisco respective platforms we have got, Catalyst and Meraki, in a simple way. This is pretty much last slide. So especially if you look at Splunk's effect, it's all about data details in reality, and which essentially means network engineers are connecting, turning more of data management resources, because they are the one who is going to look at the data. Because if you want to use data properly, that essentially means why are you having data? So they are basically looking at data and basically using information they have got to troubleshoot things, making the serviceability better, and addressing the challenges as soon as possible in reality. And this is one of the things where if you are running Cisco WAN or SD-WAN or Meraki thing, with Splunk integration, you could have visibility about your security inspection, you could have visibility about network observability stuff, you could have visibility about infrastructure you might have got there. And last part, which is before I send it to Jeffrey, is about AI assistant, right? At the moment, we have multiple phases. The phase one, what we have got is about enablement. That essentially means, for example, you're talking about or looking at a WAN platform, a cloud, a networking platform, or maybe a Meraki thing. The first question as an consumer, as an engineer, you're like, how can I configure this? How can I enable that? Like we had a question about like what we do. So with this initial phases, you could ask question like, hey, I want to enable this. What are the configuration steps? Can you guide me? Can you help me? So it can enable, it can give you information of configuration guide and resources, collaterals, and things. That's the phase one we are looking at. We have got basically. The phase two, what we are looking is like serviceability as well. So that essentially means in addition to enabling the consumers, it is also going to give you information like where the problem is or could be, and also what are the sites, what are the sites are up, what are the applications are doing bad, how is the links are doing, how the things are going there. Plus, it should be able to upload admin tech to the tech places as well. And third could be more of policy and template definitions in reality. With that, Jeffrey, I would like to invite you back on the stage.
Thank you, Prashant. So Prashant brought a lot of the principles to life with a little bit more technical examples, architectures, and stuff like that. So I'm going to wrap it up and show you where we started. We started out with this diagram again, things that we can control and not control, and then the principles that came about to abstract all this. Now, if you guys think about it, what we discussed is almost like an akin to when we were learning the OSI model, where we had 7 different things. But when you put it into practice, it's very hard to discern between the different layers, right? Well, it's kind of the same thing on these principles. They are all interrelated somehow, and they feed off of each other. So always think security, infrastructure, visibility, all these things are integrated into each other. And all this stuff has been unified, as Prashant was mentioning, as into one place. Common hardware. There was a question on the WebEx space, where do we see all these platforms? Well, that's going to be one of the main announcements this week, which is one hardware for routers now. Similar to what we've done on wireless and switching, now we're going to have one router to rule it all. No more 2 or 3 different flavors. It's just going to be a different OS experience. Either or,
Yep.
for now. For now. Yes, that's going to be either or for now. And again, this is part of the unification process. Yes, sir?
When does that come out?
You will see some of this stuff this week.
Oh, firepower.
Good answer.
So the world of solutions will have some of these devices on display. Notice that in my WebEx response, I called it Secure Router. Hint, hint, you'll see more of this stuff later on this week. And last but not least, the reason why this session on these WAN principles is today on Monday, so you can go explore the rest of the week how you can fill in and apply these principles and what else you can apply. So remember, Zero Trust helps you simplify your WAN design. As much as I would love to tell you about IPv6, it really doesn't matter. Zero Trust will get you out of trouble. Second, we have a lot of amazing capabilities in all of our platforms, including FTD that was mentioned over there. It doesn't really matter. We want to make it easy for you to consume it by making some architectural changes to how we deploy firmware, or we're also making it easy for you guys to actually consume it on your own. So one of the things that Prashant mentioned earlier about workflows, guess how much we're going to charge for workflows, which is being introduced this week? Somebody said 0. Yes, imagine that. Cisco giving something away because we want you to actually use our tech. It's there. It's amazing. We invested in it. Let's put it to use, and we want to make that barrier to entry easy. And last but not least, we're in the AI era. We need data. Generate data wherever you can. We have a lot of platforms, whether that's Thousand Nights, like was mentioned, or the Splunk TAs that were discussed. Everything and anything that we are doing will generate some kind of data, whether it's NetFlow, Syslog, MQTT, you name it. We're investing a lot to increase that visibility, so that way we can enter this AI era with data. Without data, none of this works. So as we depart and end our journey, we know you guys have a lot of pressure on yourselves. It's a very uncertain world. You're being asked to do more with less, and you want to do it fast. So take these principles you learned today from us, and don't build for resilience. Resilience is a thing of the past because you're more in survival mode. You want to build so you can thrive and actually do stuff and simplify. That's one of the hardest things to do, is to simplify things. But we know you can do it. So go explore this week. Fill out your surveys. Ask questions. We'll be here all week. Go to Meet the Engineer. Go to World of Solutions. Look at the new platforms. And with that, thank you very much.
Thank you so much. Thanks for your time.